All right, so now that I've done one, I want you to try one all by yourself. I want you to pause the video. I want you to look at try it number 1, and I want you to find me all the x values for which the function is increasing or decreasing. So the intervals in which this function is increasing or decreasing. Locate all points where the tangent line is horizontal. All right, so here's our function, f of x. It is 2/3 x cubed minus x squared minus 4x plus 2. And if we want to figure out first where our function is increasing or decreasing, before we can figure out where our derivative is positive or negative, we first have to figure out our critical numbers. Because you should never ever be just blindly testing numbers. You shouldn't be plugging in 1 and 2 and 3 and 4 and 5. Because how do we know it doesn't change at a decimal? It could change from being positive to negative at 4.3, and you would never test that, right? And so before we can figure out where our function is positive or negative and start to test numbers, we have to find our critical numbers first. That's where our derivative equals 0 or where our derivative doesn't exist. Before we do that, we obviously have to find the derivative. So did you do that? I ended up getting a derivative of 2x squared minus 2x minus 4. Now that I have the derivative, you should have been finding your critical numbers. That's where your derivative equals 0 or does not exist. In this case, we just have a polynomial function, so it won't not exist. It will always exist, I guess I should say. But there are some places where it might equal 0. That's also the same places where the tangent line is going to be horizontal. So it'll answer that part of the question. So let's take our derivative, set it equal to 0, and solve. I'm going to factor out a 2. I'm going to factor some more. I'm going to set each term equal to 0. And I ended up getting critical numbers at x equals 2 and negative 1. Hopefully you did too. Again, those are all the places where my derivative equals 0, or where I have a horizontal tangent. Now, if my derivative is only 0 at 2 and negative 1, well, let's figure out what it is on all the other intervals. If my derivative is positive, I know that my original function is increasing. If my derivative is negative, then I know that my original function is decreasing. So here we go. Let's make a sign chart and test values in each interval. On this problem, you should only have to test 1, 2, 3 different numbers. Because we've narrowed it down and we've found those critical numbers, you should only have to test 3 numbers in your derivative. Again, you should never be testing blindly. I'm going to test a number before negative 1, in between negative 1 and 2, and then a number greater than 2. Remember, we're testing these numbers in our derivative. We want to figure out if our derivative is positive or negative. I tested negative 2 and I got a positive number out. I tested 0 and I got a negative number out. And I tested 3 and I got a positive number in my derivative. So that means my function is increasing from negative infinity to negative 1, and then again from 2 to infinity, because my derivative was positive. My function was decreasing from negative 1 to 2, because my derivative is negative. So I know now exactly where my function goes up, goes down, and even has a horizontal tangent, where it's increasing, decreasing, and where it has those little hills and valleys. All by looking at my derivative, finding my critical numbers, and then testing values in each interval.